This is now page 4, I believe. It says the graph of the derivative of f is shown in the figure above. Always read it carefully. This is the derivative. This is not the actual function. So which of the following could be a graph of f? Well, if this is the derivative, when the derivative is negative, the function is decreasing. So our function needs to be decreasing, and then increasing, and then decreasing again. So no thanks, no thanks. Needs to start by decreasing. Remember that, okay? This starts by increasing, no thanks. This starts by increasing, no thanks. This one starts by decreasing. Let's see. It decreases, then it needs to increase, then it needs to decrease. Boom, there it is, E. Okay. Next one. At what point on this on the graph of this thing here is the tangent line parallel to this line here? First thing I'm going to do is figure out the slope of this line, so I'm going to put it in point slope form. Okay, so y equals 1/2 x minus 3/4. Okay, so the slope is 1/2. So we're looking for a point on this function that's tangent to this line here. So it needs to have a slope of 1/2. Well, the slope of the tangent line is just the derivative. The derivative of this is just x, okay? So we want to know at what point is the derivative, which is literally just x, equal to that slope, which is 1/2. Well, it's when x is 1/2, so x needs to be worth 1/2. And you probably think you're done. And it says, at what point on this graph is it? Well, it's when x is 1/2. Look at all the answers. Well, it's going to be one of these two. Only one of these is actually on this function, though. And to figure out what it is, take 1/2, plug it in for x. So when you plug in 1/2 here, 1/2 squared is 1/4. 1/4 times 1/2 is 1/8. So it's actually b. This point, to be clear, isn't even on this function.